Hello, geometry students. This is Mrs. Hefty, and we are in section 2-5, which is on postulates and paragraph proofs. Postulates are statements that we accept as being true. Postulates describe fundamental relationships in geometry. We've even learned some of these things through the definitions that we've already talked about. Let's take a look at the postulates that you have in your paper. You don't need to know the postulate numbers. You just need to know what each postulate says. That through any 2 points, there's going to be exactly one line. If I give you 2 points, you can draw a line through those 2 points. We've already talked about that. Through any 3 non-collinear points, there is exactly one plane. Remember, we've talked about when you have 3 non-collinear points, that's how you name a plane. So I have points A, B, and C. If I have 3 non-collinear points, then I'm going to have a plane. A line contains at least 2 points. If I'm going to have a line, there have to be at least 2 points on that line. Postulate 2.4. A plane contains at least 3 non-collinear points. Again, this is what we talked about earlier. When we name planes, we need 3 non-collinear points. We could have 4 or 5, but we must have at least 3. Postulate 2.5. If 2 points lie in a plane, then the entire line containing those points lie in the plane. So if you have a plane, and you have 2 points, all of the points on that line are in that plane. 2.6 states, if 2 lines intersect, then their intersection is exactly 1 point. And we've talked about the intersection of 2 lines being a point before. So here we go. And their intersection is this point right here. Postulate 2.7 states, if 2 planes intersect, then their intersection is a line. And we talked about this during class. Remember how we talked about the 2 walls, how they're intersecting, and then the corner, it's not really the corner, but you know, where the 2 walls are intersecting, there's actually a line right there. So whenever you have 2 planes intersecting, their intersection is always going to be a line. Let's take a look at our examples now. Determine whether each statement is always, sometimes, or never true. Number 1, a line contains exactly 1 point. Now remember, just a few minutes ago we said that in order to have a line you have to have 2 points. So this problem is never true. A line has to have 2 points. Example number 2, non-collinear points R, S, and T are contained in exactly 1 plane. Think about this for a minute. Is that always true, sometimes true, or never true? When we talk about non-collinear points, remember it takes 3 non-collinear points to make up a plane, exactly 3. So this is always true. Oopsie, plane. Need an E on the end there. Example number 3. Any 2 lines L and M intersect. When I have 2 lines, they're going to intersect. Is that always true, sometimes true, or never true? Okay, 2 lines can intersect, yep, and if they intersect, it'd be in a point, but are they always going to intersect? This is sometimes, because you could have parallel lines. And if you have parallel lines, then they are not going to intersect. You could also have what's called skewed lines, where the 2 lines are in different planes and they're never going to intersect. Let's take a look at example number 4. If points G and H are contained in plane M, then GH is perpendicular to plane M. So what they're saying here is, if you've got a plane and you've got G and H, and they're in that plane, then when I connect them and make a line, it's going to be perpendicular to the plane. Now, perpendicular would be stabbing through people. That pencil would be held perpendicular to that paper. So this is never going to be true. Okay, remember, never. It's going to be perpendicular to the plane, then it has to be in another plane. It would have to be stabbing through. Remember how I held that pencil and stabbed it through the paper? I could do that, but then that line is going to be perpendicular, and they're in two different planes. Plane R and S intersect in point T. When I have two planes, remember your walls? The walls intersect in a line. Two planes are not going to intersect in one point. They're always going to intersect in a line. So that's never true. Number 6, if points A, B, and C are non-collinear, then segments AB, BC, and CA are contained in exactly one plane. So what they're saying there is I've got a plane, and I've got point A, got point B, and I've got point C. And then they say that when you connect them, those segments are also going to be in the plane. Now, it seems like every time I do this lesson live in class, some students are going to say, well, this isn't always true. What about if it's out here, it's away from the wall? Well, then there's a plane running through those 3 points. So the 3 points are always going to be in a plane because that's what it takes. 3 non-collinear points are going to make a plane. And then when you connect those line segments are also going to be in that plane. And if you're still confused on that, I can show you a model of that in class if you ask me to. So this statement here is always true because those 3 points are going to make a plane, and then when you connect them and make them line segments, those line segments are also going to be in that plane. All right, that's all for our lesson. You guys have a great evening, and I'll see you in class tomorrow.